Okay. So what we have discussed in last lecture, we have discussed about Altera Max 7000 CPLD, right? And its architecture of its different blocks, right? So again, I will summarize it in brief. So any if the basic CPLD structure has three important blocks: IO input output control block, then lab, right? That is logic array block, and programmable interconnect array, that is PIA, right? And this PIA's role is to connect each lab with each other along with input output control block. And in each particular single block, that is a logic array block, how many number of macros are there? 16, with the group of 8 and 8, right? So this is the and along with these all architecture, there are 4 control pins, right? Output enable 1, output enable 2, then global clock and global clear reset and global clock reset. So these are the 4 control pins are also there for every CPLD. Along with this is the basic architecture. See, uh, just remember one thing: you consider any company, any CPLD, any series, okay, but this basic architecture is not going to change. There may be a kind of modification, right? For example, there may be a more than 16 blocks, so these kind of modification can be there, right? Or there can be a more number of input output pins, right? Or the what we can say, there can be a more number of control pins along with these 4 pins. But the thing is, this is the basic requirement that should be there. Along with that, what addition with that, that is the only thing. बरोबर आहे. म्हणजे जे बेसिक आर्किटेक्चर आहे ते असतंच, त्याच्या बरोबर ऍडिशनली काय आहे तेवढं फक्त तुम्हाला बघायचं आहे, राईट? विथ इच एव्हरी सिरीज. कारण आपण जेव्हा नेक्स्ट सिरीज डेव्हलप करतो तेव्हा काहीतरी ऑब्विसली त्याच्यात आपण ऍडव्हान्समेंट करणार आहोत, बरोबर आहे. when that Altera had developed the first CPLD, that is 5000 series. So obviously when they are going for the 7 Altera Max 7000 series, obviously some advancement will be there or should be there. When they are going for the Altera Max 9000 series, along with the basic structure of that 7000 and 5000, again there are some additional features. Likewise, the what we can say, the higher end series has been developed. But the thing to remember is basic architecture won't change. Basic architecture is same for every case and for every CPLD. Okay. Now today we will discuss about the Xilinx CPLD, that is XC9500 family. Okay. Now this XC9500 CPLD family, this provides, these are the some important features, or you can say important specification of this Xilinx XC9500 family, that is CPLD again. Okay. Now what are its important features? So first thing is, this CPLD family provides advanced in-system programming and test capabilities for high performance general purpose logic integration. Okay, that means this XC9500 family is more advanced version of its previous what we can say CPLD series, right? Xilinx also have developed mini CPLD series, right? This XC9500 is the most advanced one. Okay, so what are the features of this XC9500 family? So it has advanced in-system programming and test capabilities for higher performance. Then all devices are in-system programmable for minimum 10,000 program per erase cycles, right? All devices, that means all that logic array blocks are in-system programmable for minimum 10,000 program per erase cycle. Now imagine what is the programming capacity of this XC9500 family, right? Then it is a extensive IEEE 1149.1, that is JTAG boundary scan support is also included. मी तुम्हाला सांगितलं की आजकाल सगळ्या बोर्डला JTAG पोर्ट असतं, right? And by using that JTAG standard boundary scan, you can easily test or use easily verify the working of that hardware or that particular what we can say chip. Okay, so this JTAG 1149.1 standard, that port and its compatible hardware is already there in this XC9500 CPLD board, and it is the what we can say best advantage we consider, that your testing is now very easy. Okay, whenever you find JTAG code, your testing job is already half done, half done. Your role is to just you connect that what we can say cable, JTAG cable. Okay, there is automatic test pattern generation is also there. Now your role is to just give the scan input and observe the scan output. That's it. This much simple job is remaining for you. So if it is having JTAG port or JTAG support, it's great thing actually. Okay, then logic density of this XC9500 devices ranges from 800 to over 6400 usable gates with 36 to 288 registers. Okay, so these are the variety of what you can say variety range of the gates and registers are available with this CPLD family, that is XC9500. Then multiple package options and associated input output capacity is also available. Then this Xilinx XC9500 family is fully pin compatible, allowing easy design migration across multiple density options in a given package footprint. That means this particular CPLD family is available in different packages. Okay, so in your LIC subject or integrated circuit subject, you might have studied about the different packages, right? So this CPLD XC9500 family is also available in a variety of packages. Then next merit or next specification you can say is this XC9500 architecture feature addresses are a requirement of in-system programmability. Okay, and this enhanced pin locking capability avoids costly board rework. That means uh, if you have fixed your input output pin number, okay, say for example if you require 10 inputs 10 output, then you can lock other input pins so that any data will not go in and come out from that pins. So this facility is available with this CPLD Xilinx 9500 family. Then next feature is, it is an expanded JTAG instruction set that allows version control of programming, that patterns and in-system debugging. This we have already discussed. So it is a JTAG support board. So advanced JTAG instruction set that allows a different programming patterns and in-system debugging. That means again it is what we can say, it is to deal with the testing of your circuit. So it is most easier for this CPLD XC9500, and that is of Xilinx company. Okay, then in-system programming throughput, the full device operating range and the minimum of 10,000 program per erase cycle provides worry-free configurations and system field upgrades. Okay, will you imagine 10,000 program per erase cycle? 10,000 program per erase cycle. That means for a single erase, right, you can write 10,000 programs per erase cycle. Means for a single erase cycle, 10,000 programs can be written. Then you can erase that. Then it will get full. Then you have to erase something and then you have to write new programs, right? So it's a like we can say beyond the imagination capacity. It's a good thing actually. Next feature is advanced system features include output slew rate control, then user programmable ground pins to help reduce system noise, right? So you can control the slew rate of what we can say particular output. Then you can also it is provided with the user programmable ground pins to help reduce system noise. That means user programmable ground pins means what? Normally we are considering ground at 0 volt, right? आपण normally ground कशाला consider करतो 0 volt साठी. पण suppose जर का there is a noise, right? Some spikes may be there or some what we can say internal thermal noise may be there. So because of that, you can change that ground level. That means now by the what we can say, your programming, you can now set your ground at the 2 volt. That means now the ground is treated as a 2 volt. That means above that noise level, so that the noise will not get added into your uh, what we can say execution, right? Because see, any electronic device, any electronic chip, any electronic component has some noise effects that you have studied. It may can have the if there is a lot of conductors and a lot of capacitors that are surrounded to it, then there may be a kind of crosstalk noise, thermal noise is there. Then heat is also one of the reason to produce what we can say noise. Then there is if that particular chip or particular IC get overheated, then thermal runaway can occur. So there may be a different types of noises are there. So to avoid this, you can set your ground level by as a user. बरोबर आहे. म्हणजे नॉट नेसेसरी की तुम्ही 0 voltच तुम्ही धरली पाहिजे, तुम्ही ती बदलू शकता. यू कॅन इवन गो डाउन टू अ निगेटिव्ह साइड. यू कॅन say -5 is the ground, no problem. So this facility is available for this 9500 family. And the last and very important feature is input output may be configured for 3.3 volt to 5 volt operation, and all output provides 24 milliampere drive. बरोबर आहे. म्हणजे हे करंट आणि व्होल्टेज रेटिंग दिलेले आहे. किती आहे व्होल्टेज रेटिंग? 3.3 volt to 5 volt, right? Or you can say 3 volt to 5 volt, and current is 24 milliampere. That is the output current that you can get. So these are the some features of this Xilinx CPLD XC9500 family. Then this is the architecture. This is the architecture. Okay. Now this is the function block that you can say it's a lab, that is logic array block with macro cells. It is available there. These are the input output control blocks. Okay, this is the JTAG controller with JTAG input and JTAG output port. Then in system programming control is also provided. That means see, you can able to see here, this architecture reveals the basic block diagram is same. Okay, इथे पण काय आहेत, हे लॅब आहेत, फक्त अरेंजमेंट वेगळी आहे. इथे पण इनपुट आउटपुट कंट्रोल ब्लॉक्स आहेत. बरोबर आहे. फक्त ऍडव्हान्स फीचर्स काय आहेत, जेटॅक कंट्रोलर आणि इन सिस्टीम प्रोग्रामिंग कंट्रोलर, राईट. हे ऍडव्हान्स दिलेले आहेत, पण हे बेसिक ब्लॉक डायग्राम जे आहे दॅट विल रिमेन सेम. अरेंजमेंट ऑल्सो मे बी डिफरंट, अरेंजमेंट मे बी ऑल्सो डिफरंट. ओके, सो this is the architecture of this Xilinx CPLD XC9500 family. Okay, and this fast connect second switch matrix is again you can say it is a PIA, that is programmable interconnect array. This connect matrix is nothing but PIA. Okay, so that connects this IO blocks, input output blocks. This connects with this in system programmable, this JTAG controller. Okay, there are so many interconnections, and this particular sign indicate it is of a bus that size 18-bit. This is a bus that is of size 36-bit. So these are the what you can say typical architecture of this Xilinx CPLD family. Components same आहे, फक्त arrangement वेगवेगळी आहे, right? Now this is the XC9500 macro cell. बरोबर आहे. आपण अल्टेरा बॅक 7000 चं मॅक्रो सेल आर्किटेक्चर शिकलो. हे Xilinx XC9500 चं मॅक्रो सेल आर्किटेक्चर आहे. ओके, द सेम थिंग यू कॅन फाइंड देअर. सो दिस इज द additional product term. This is the product term allocator. Okay, then again this is the additional product term. Then this product term allocator is connected with different multiplexer, right? And that multiplexer is global set reset and global clocks. These are the what we can say control pins or control signals you can use. And again this multiplexer connects with this D flip-flop and again SR flip-flop also. It is what we can say 2-in-1 flip-flop is there. This is can be a D flip-flop or toggle flip-flop or can be a SR flip-flop. Okay, and finally this output is given to the that PIA, that is programmable array, programmable interconnect array. Okay, and this is to the this output and product of term output is given to the IO input output blocks. So this is the typical macro cell architecture with what we can say of that Xilinx XC9500. Okay, this is the macro cell architecture of Xilinx XC9500 CPLD family. Okay, now we will discuss the advantages of CPLD. Okay, we will discuss the advantages of CPLD. Okay, now why we are going for the CPLD? So first thing is CPLDs can realize a reasonably complex design such as graphic controllers, LAN controllers, UARTs, then cache control and many other control very easily, right? तुम्हाला लॅन कंट्रोलर माहित असेल, ग्राफिक्स कंट्रोलर माहित असेल, बरोबर आहे. सो इन युअर कॉम्प्युटर देर आर सो मेनी ग्राफिक्स कार्ड्स टू actually to what we can say drive that graphic card. You require that graphic controller. So that graphic controller is nothing but kind of ASIC and it is built with the help of CPLD. ते ग्राफिक कंट्रोलर मध्ये आपल्या जो लॅपटॉप मध्ये किंवा तुमच्या पीसी मध्ये जो असतो, बरोबर आहे, ग्राफिक कार्ड तुम्हाला इन्सर्ट करावं लागतं, पण ते ग्राफिक कार्ड कंट्रोल करायला एक कंट्रोलर लागणार, दॅट इज द ग्राफिक कंट्रोलर. सो that graphic controller is nothing but one kind of ASIC and that is built with the CPLD, right? So these many complex designs can be easily realized with using CPLD. Okay, the next is the significant advantage of CPLDs is that they provide simple design changes through reprogramming, right? That means all commercial CPLD products are reprogrammable. Okay, because you know that Xilinx XC9500, how many program per erase cycle it provides? 10,000. So will you imagine how many times it is reprogrammed? Okay, so it provides a what we can say a large cycle of reprogramming. So our commercial CPLD products are reprogrammable. This is again one of the biggest advantage of CPLD. Then higher speed of operation, but obvious because hardware itself is a parallel, right? With what we can say a large number of macros are available, large number of input output pins are available, and along with this large number of erase cycle is also available. So with combined effect of this is the speed is tremendously high. That means higher speed of operation. And the last advantage is predictability of circuit implementation is one of the strongest advantage of CPLD architecture. That means you can predict the circuit implementation, right? This is the one of the strongest advantage of CPLD. Predictability means what? How many actually micros or how many number of input output blocks your design may utilized in that particular CPLD. म्हणजे त्या CPLD मधले किती मायक्रोज आणि किती इनपुट आउटपुट ब्लॉक्स तुम्हाला लागतील हे तुम्ही कॅल्क्युलेट करू शकता. दॅट मीन्स इट इज प्रेडिक्टेबल. Only this many part of that particular circuit or sorry CPLD is required. हे तुम्ही कॅल्क्युलेट करू शकता, right? Means these many macros I will require, these many IO input output blocks may require, these many lab, that is logical array block I will require. So you can predict that, right? By observing your design code, by observing your design. So this is also one of the strongest advantage of this CPLD, that is predictability. Okay, so this is about the CPLD. Now we will talk on FPGAs. Okay, so what we can say next part of the integrated circuit or next category of the integrated circuit, that is FPGA. So what is this FPGA? That is the field programmable gate array. Okay, FPGA is nothing but field programmable gate array. Okay, now what is this? These FPGAs are the digital integrated circuits, or you can say ICs, that contain configurable blocks of logic along with the configurable interconnects between these blocks. Okay, this is the simple definition of FPGA. What do you mean by FPGA? FPGA are the digital integrated circuit, that means ICs, that contains configurable blocks of logic along with the configurable interconnects between these blocks. That means it has configurable logic blocks and configurable interconnect to connect that block. So this is the definition of FPGA. Now This FPGA is an FPD featuring a general structure that allows very high logic capacity. Okay, this field programmable design. This particular field programmable design features a general structure that allows very high logic capacity. That means, as compared to CPLD, you can again design more complex design with the help of FPGA, right? You can design more complex design with the help of FPGA. FPGAs are more narrow logic sources. Okay, these are the more narrow logic sources. Then FPGA also offers a higher ratio of flip-flop to the logic resources than do the CPLD. That means, as compared to CPLD, FPGA has large number of hardware capacity. That means a large number of macros and large number of what we can say CMOS that FPGA can accumulate, so that the capacity of design as well as the what we can say space required to occupy that design is provided by the FPGA is much larger than the CPLD. बरोबर आहे. म्हणजे CPLD मध्ये जो गेट रेशो असतो, फ्लिप फ्लॉप टू लॉजिक रिसोर्सेस जो रेशो असतो, तो FPGA मध्ये त्याच्यापेक्षा जास्त असतो. म्हणजे काय, तर नंबर ऑफ कॉम्पोनंट्स इन व्हेरी इझी लँग्वेज यू कॅन सी number of components are in FPGA are more than the CPLD, right? In very simple language. Then this FPGA nowadays again they are developing into analog programmable gate array, that is APGA, right? So this part is under research, and this FPGA is nothing but again high capacity PLDs only. Okay, upon while discussing the what we can say tree diagram of the integrated circuit, full custom, semi custom, and PLDs. So PLDs in again two categories, CPLD and FPGA. So this FPGA is again nothing but the what we can say subcategory of this PLDs. So in very simple language you can say FPGA as a high capacity PLDs, right? You can say it is a high capacity PLDs. Even you can say same thing to CPLD also, like. So there is not much difference between the CPLD and FPGA. Okay, CPLD आणि FPGA मध्ये तसा फरक नाहीये, फक्त फरक कशात आहे, कॅपॅसिटी, राईट? फ्लिप-फ्लॉप टू द लॉजिक रिसोर्स रेशो हा जो आहे तो CPLD आणि FPGA चा वेगवेगळा आहे. हा फरक आहे बेसिक, बरोबर आहे? फ्लिप-फ्लॉप्स टू लॉजिक रिसोर्सेस रेशो म्हणजे काय? सो फॉर एक्झाम्पल, सपोज तुम्हाला एक एक्झाम्पल म्हणून आपण कन्सिडर करूया की 5 फ्लिप फ्लॉप इम्प्लिमेंट करायचे, बरोबर? तर त्यासाठी लागणारे जेवढे लॉजिक रिसोर्सेस आहेत ते CPLD पेक्षा FPGA मध्ये जास्त असतात. इन व्हेरी सिम्पल लँग्वेज एवढं लक्षात ठेवा. एक फॉर एक्झाम्पल तुम्हाला एक 10 फ्लिप फ्लॉप किंवा 5 फ्लिप फ्लॉप इम्प्लिमेंट करायचे, तर जेवढं तुम्हाला आर्किटेक्चर किंवा जेवढे ब्लॉक्स लागणार आहेत, बरोबर आहे, तेवढे नंबर ऑफ ब्लॉक्स हे CPLD मध्ये च्या कम्पेअर पेक्षा FPGA मध्ये जास्त असतात, बरोबर आहे? म्हणजेच याचा अर्थ काय होतो, तिथं जास्त नंबर ऑफ फ्लिप फ्लॉप्स तुम्ही इम्प्लिमेंट करू शकता. दॅट मीन्स हार्डवेअर इज मोर स्ट्रॉंगर इन FPGA ऍज कम्पेअर्ड टू CPLD. FPGA मध्ये हार्डवेअर हे स्ट्रॉंग असतं. नंबर ऑफ कॉम्पोनंट्स आर ऑल्सो ग्रेटर दॅन द CPLD. ओके, सो दिस इज द डिफरन्स बिटवीन FPGA and CPLD, and these are the features of this FPGA. Again, these are the few more features of FPGA that we will discuss. A very high logic capacity, right? कारण number of components जास्त आहेत त्यामुळे logic capacity पण जास्त असणार आहे. Used for implementing digital hardware, that is but obvious. Customized as per needs of the user by programming, right? So you can what we can say design the ASIC with the help of the FPGA, right? ASIC म्हणजे पण एक प्रकारचं FPGA असतं, but that is not a general purpose FPGA. It is application specific FPGA, that is the ASIC, you can say, right? Low starting cost and low risk. Okay, once you have what we can say manufactured that device in a bulk quantity, so starting cost to program FPGA is very less, and also risk involved is also very less. Okay, configurable as many times as we want. Okay, means similar to the CPLD, this FPGA also have more number of cycles, right? more number of program per erase cycles than the CPLD. बरोबर आहे. CPLD पेक्षा ह्याच्यात अजून जास्त प्रोग्राम पर इरेज सायकल्स असतात FPGA मध्ये. त्यामुळे तुम्ही ह्याला किती वेळ कॉन्फिग करू शकता as you want. Okay, so these are the some of the features of FPGA. Okay, now for your syllabus they have mentioned this Altera Flex 10K FPGA series, right? So this FPGA is there in your syllabus. So this FPGA we will discuss in next lecture. Okay, probably this will be the last point of unit number 6, that is architecture of commercial devices. Okay, so this Altera Flex 10K FPGA we will discuss in next lecture. Okay, today we will stop here. If you have any query, you can ask me right now. समजलंय का सगळ्यांना?